This is the case of total anomalous pulmonary venous connection. So all four pulmonary veins drain into right atrium through something, not into left atrium. That is called total anomalous pulmonary venous connection. In this case, what you see in this image, you can easily see this is right ventricle, this is right atrium, this is left ventricle, left atrium, and this is pulmonary venous confluence. All four pulmonary veins joins together and make it pulmonary venous confluence. From there, as one straight vein comes that joins, in this case, left innominate vein. Finally, left innominate veins join with right innominate vein and make superior vena cava, and that drains into right atrium. So in this case, what is the pathway? That all pulmonary veins joins together making pulmonary venous confluence. That from there pulmonary straight vein comes, that straight vein joins left innominate vein, from left innominate to right innominate, left and right both innominate veins join together and make it SVC, superior vena cava, and then that drains to right atrium. Let us go to next image. Again the same thing. You can easily see right atrium, right ventricle severely dilated. In moving image, you can see this is right ventricle, right atrium. This is ASD, very small ASD. This is pulmonary venous confluence. This is left atrium. This is left ventricle. Again same image. Now color flow. You can see mild tricuspid valve regurgitation. Here you see the bluish flow. That is from right ventricle into right atrium, that is tricuspid regurgitation. Here ASD is there. From normally the flow is from right atrium into left atrium, because left atrium receives blood only from right atrium, because it does not receive any pulmonary vein, so blood has to come from right atrium into left atrium. So flow has to be right to left in ASD in case of total anomalous pulmonary venous connection. This is pressure across tricuspid valve. That is the peak velocity of TRZ. You can see it is more than 4. So right ventricular systolic pressure is highly raised in this case. You can see easily right atrium, this is right atrium, the right ventricle, this main pulmonary artery severely dilated, this is aorta, and this portion, this is also descending aorta. You see, this is descending aorta. Again the apical four chamber view. Right atrium, right ventricle severely dilated. You can see pulmonary venous confluence. Now this is supraesternal long axis view. Here the long axis means the whole aortic arch is seen in this axis. That is why it is called long axis. It means long axis of aortic arch, because in this view you see whole aortic arch. This is ascending aorta, this is arch of aorta, this is descending aorta. So you can see here right brachiocephalic, then right common carotid, then right subclavian. 3 branches coming from arch of aorta. This is superior vena cava. You can see the superior vena cava is highly dilated, severely dilated superior vena cava, only because of it receives blood from pulmonary veins also. That is why it is severely dilated. You can see this is again arch like look, but this is supra vena cava. So this is left innominate vein. Here the right innominate vein, left innominate, both joined together from supra vena cava. But in this case, left innominate vein is quite dilated because it receives blood from a state vein. That state vein receives blood from pulmonary venous confluence. Pulmonary venous confluence receives blood from all 4 pulmonary veins. So sequence wise, you see all pulmonary veins joined together make pulmonary venous confluence. From there, state vein comes. State vein, that state in orientation, so that is called a state vein. This is a state vein that joins left innominate vein, then left innominate vein, right innominate vein, both joined together to form supra vena cava, and that drains to right atrium. That is why it is called supracardiac variety of total anomalous pulmonary venous connection, and you can say it drains through supra vena cava. If whenever you find two arcs, you see here, this is arch, this arch of aorta, again arch like look, just above, just superior to arch of aorta, that is total anomalous pulmonary venous connection, and this is left innominate vein that is dilated. So arch above arch, that is total anomalous pulmonary venous connection. You can easily see this image. Next image. What is the difference between color in those two different arches? In case of normal aortic arch, you will find blue in this is blue, this has blue color, that is downward flow. But in case of this one, red in flow, because a state vein takes blood from pulmonary venous confluence and goes superiorly to drain into left innominate vein. So here the color is red. So whenever you find red color, here the flow is red in color, but in case if it would be normal aortic arch, then it would have blue color because it is descending aorta. Descending aorta has blue color because the image is being taken from superior one, supraesternal window. So color is blue. But in case of total anomalous pulmonary venous connection, you see this color is red. So color is direction is upward, but in case of descending aortic arch, color is blue, that is flow is downward. That is why you can easily make, try to understand, you can easily make, this is the total anomalous pulmonary venous connection. Now you can clearly see the color. This is blue color, here red color. This is blue color, descending aortic arch, this is red color. So whenever you find left innominate vein dilated, supra vena cava dilated, and no pulmonary vein is exactly draining into left atrium, then you have to suspect total anomalous pulmonary venous connection. Again you can see two arches. This arch has red flow is here the upward, here the downward. So this part, right part has blue, left part has red. But in case of normal aortic arch flow, what do you expect? Here is blue, here is red, because ascending aorta has red color, descending aorta has blue in color, because we are seeing the view from suprastral window, that is from superior one. That is the point to understand in this case. And there is no flow obstruction because no significant turbulence. So in case of total anomalous pulmonary venous connection, where the state event drains joins something, at the part where it joins, sometimes obstruction remains there. If the flow obstruction is there, then the child becomes more symptomatic. I mean, the infant becomes more symptomatic, and in that case, the operation is required urgently. Here in this case, baby is 2 months old, and baby has already developed significant amount of right ventricular systolic pressure. So operation is needed early in this case. In the first month of the age is best time to operate. If second month, third month you can do, but better is when before the significant pulmonary artery hypertension develops, the child should get operation done, and a corrective surgery should have been done before. So that is ultimately the point to note in this case. So whenever you find this kind of image, 4 chamber view, all four events, you see one chamber just superior to left atrium. Here the view is apical 4 chamber view. So this is the apical portion, this is the most away from the apical portion, that is the superior one, this is the inferior one, because apex is inferior compared to the base of the heart. So this is left atrium, this is a structure that is superior to left atrium, that is orientation wise this is superior. Any chamber like a structure just above the left atrium, that means case has to be total anomalous pulmonary venous connection, that is receiving the pulmonary vein in a state of left atrium. So left atrium has to get blood from right atrium through SD only, and that blood goes into left ventricle, that goes into aorta, and that goes into all our systems. So this is the case of total anomalous pulmonary venous connection. Venous connection is through left innominate vein, and this is called supracardiac variety of total anomalous pulmonary venous connection. Thank you.